Thank you very much. Good morning. Welcome to everybody. This is your favorite psychology teacher, Dr. Chris Roddenberry, coming to you from my office in Wake Tech South Campus. How's everybody doing today? I see we have a couple of viewers here. Why don't you go ahead and check in on the chat bar and let me know you're there. Text me a hi, hello if you would. Good to see everybody. Thanks for coming today, and I do appreciate the almost 30 people that came to the Wednesday webinar last night. I hope you had a good time and learned a little bit about psychology last night. Rylan was there, Cielito was there last night. Good to see both of you. Thanks. Hi, Lainey. Good to see you. Fantastic. I'm glad to see everybody in the house this morning. You know what? It is Thursday, which means this is the last lecture of the week. Yay! We had a short week, so you didn't have too much to do this week. Make sure you complete the course entry paperwork. I noticed that we still have several people. Let me see. It looks like 6 people who still have not completed the course entry quiz. If that's you, remember today is your last day to complete the course entry paperwork. If you don't do that course entry quiz, you will be dropped from this class. By tonight, you will be dropped from this class. No questions asked. Okay, don't forget, discussion board is due tonight at 11:59 p.m. and your homework for week 1 is due tomorrow night at 11:59 p.m. Good morning, Anya. Good morning, Martine. And good morning, Salem. Fantastic. It sure is good to see everybody today. So we're going to talk about the second half of chapter 1. Okay, so the research methods in psychology. Maybe not the most exciting part of this psychology class, but very, very important. And what we're going to do is we're going to introduce you a little bit to the methods by which we use to gather information about human psychological functioning. If you remember yesterday, I suggested to you that psychology is a science, and science is a standardized method of gathering observations that ensure that you gather information correctly and come to correct conclusions. So we're going to be talking a little bit about the scientific process and the research methods used in psychology today. So we're going to talk about the steps of the scientific process. Then we're going to talk about 3 broad groupings of research techniques: the descriptive research methods, experiments, and correlations. If anybody has any questions, don't hesitate to type in the chat bar. I can always stop the lecture and answer your specific questions. If you don't feel confident about answering the questions, you can always text me or email me later, and I would be more than happy to answer your questions. So let's go ahead and get started. All right, the foundation of the scientific process are these 2 things called theories and hypotheses. The scientific process is a systematic process of developing and testing theories. We use logic to guess why things happen, which are theories, and then use measurement to find out if our theory is correct. Now I'm going to go ahead and start talking about theories, but I know each and every one of you learned a definition of a hypothesis early in school somewhere. I learned that 2-word definition of a hypothesis in 8th grade, just like you did. So what I'd like to do is see somebody type in that 2-word definition of what a hypothesis is while I go ahead and describe theories. I see we've got Louis Tapia in the house as well. Good morning to you, Louis. Thanks for coming today. All right, so here's the deal. All science starts out with these things called theories. A theory is an explanation of why something happens. That's sort of a generic way to describe a theory. I could use this scientific terms to talk about phenomenon and necessary and sufficient conditions, etc., etc. But basically, a theory is an explanation of why something happens. So I could take this book right here, and I could ask the question, why does that book drop on the floor when I let go of it? Well, that's because we have this theory called gravity. Larger objects like the Earth pull smaller objects towards them. They exert this gravitational force and pull objects towards them. So that is a theory of gravity, all right? And you know what? We might have a theory of low self-esteem. You know what? I might say that low self-esteem develops as a result of lack of social interaction. People who don't have many friends develop low self-esteem. And that, in a sense, is a theory of why people have low self-esteem. I'm not saying it's true. I'm saying that it is a theory. So we test theories. After we develop a theory, we then develop a hypothesis to test that theory. All right, I see nobody has typed in the chat bar. Can somebody please give me the 2-word definition of hypothesis that you learned in school? I'm going to sit here and wait until somebody types in that definition. So go ahead and do it now, or this is going to be a long and boring class. Oh, there we go. Anya says an educated guess. Absolutely correct. I learned that same exact definition of hypothesis in 8th grade as well. Anya, do you know why they call it an educated guess? Do you know why it's educated? Do you know what educates that guess? A theory educates that guess. That's why they call it an educated guess, because it's based upon a theory that you think is right. So we first develop a theory. So I think low self-esteem is a result of lack of social interaction. So then I would develop a specific prediction that I should see in the real world if my theory is true. So let's assume that I can measure people's self-esteem. In fact, I can. There's a questionnaire called the Rosenberg Self-Esteem Scale, and it allows me to measure people's level of self-esteem. And so if self-esteem is a result of lack of social interaction, then people who have less friends should have lower self-esteem as measured on a self-esteem scale. So you know what I'll do is I find a group of people and I ask each one to tell me how many friends they have. I then give them a self-esteem questionnaire, and what I should find is that people who say they have more friends have higher self-esteem, and people who say they have fewer number of friends should have lower self-esteem. So a hypothesis would be, I believe that people with fewer friends should score lower on a self-esteem questionnaire. Now, a theory is a general statement that uses general terms. Low self-esteem is a result of lack of social interaction. Those are two very vague general terms, but I'm going to test them by using your score on a self-esteem questionnaire and the number of self-reported friends. That is a very specific, observable situation that ought to be true if our theory is true. So, Anya, educated guesses, hypotheses are educated by theories. We make a hypothesis based on our belief that a theory is true. Now, if I don't find that relationship that people with a higher number of friends have higher self-esteem scores on a self-esteem scale, then I might conclude that my theory is wrong. But if my data support my hypothesis, then I say, for now at least, I believe my theory is true. So here's how science works. A scientist develops a theory, develops a theory from reading the literature. They then test that theory with a hypothesis test. If that theory is supported, they keep it and keep testing it. If the hypothesis test doesn't support the theory, then they assume that the theory is wrong and throw it out and develop a new theory. And so science is a ever rolling cascade of theories, hypothesis test, theories, hypothesis test, theories, hypothesis test. And that's sort of how science works. So for the exam, I do want you to know the difference between a theory and a hypothesis. A theory is a general statement about a relationship between concepts of interest. A hypothesis test is a very specific, measurable event that should be true if our theory is true. And I'm even going to ask you on the homework and the test to differentiate between a theory and a hypothesis test. And remember, a theory is general and abstract. A hypothesis test is specific and concrete. I see we have Marcella Villamiziar in the class. Hi, it's good to see you too. Thanks for coming today. Okay, so your book's going to talk about the steps in the research process. In a sense, there is a set of procedures. Actually, science is a set of procedures. When we say that something is scientific, what we're saying is that researcher is following a set of steps, like a recipe, in order to examine the world and see if they can find out true statements about how the world really works. And there are 5 steps in the scientific process. As I suggested to you earlier, we're going to formulate a theory by consulting the existing literature or by walking around in the world and just seeing if we can come up with insights. For example, I don't know if this is true. They say the legend is that Sir Isaac Newton developed the theory of gravity because he was sitting under a tree and an apple fell off the tree and hit him in the head. And it led him to the insight that maybe this bigger object, the Earth, was pulling this apple, this smaller object, towards it. So he didn't necessarily read literature. He instead saw something in the world, and that gave him an insight. You can do either of those 2 ways, but typically, at least in the psychology, because we've developed so many theories, you can go into the literature and find out what people think is already going on with regard to human functioning. So we formulate a theory. That's the first step. And then, as I suggested to you, you have to test that theory by coming up with a hypothesis and doing a test to see if you can observe a situation in which your theory is correct. So we have a theory, and then we engage in we develop a hypothesis to test that theory. Okay? Now, the third step, and this is what we're going to spend most of our time talking about today, is we find a method for setting up this hypothesis test and gathering the data. Gathering data to support or refute a hypothesis is done by selecting a research method. And a research method is nothing but a strategy for gathering data. And we're going to talk about 3 basic research methods that I'll bet you've already heard before. There's the descriptive method, there's the correlational method, and then there is the experimental method. And each and every one of these methods has strengths and weaknesses. After you gather these data, you then have to analyze these data. That is, you do your statistics, whether it's a t-test, an analysis of variance, a multivariate analysis, a factor analysis. You do some sort of statistical test to analyze the data and see if the data support your hypothesis test. Okay, I just want to stop the lecture for just a second and say hello to Cosette Rieflin, a student from Spring. You know what? We had another student in here yesterday, Cosette, from the Spring class, coming back to say hello. And it is, of course, great to see you. Thanks for stopping in and saying hello. Everybody, if you would, please give Cosette a round of applause. Thank you very much. Cosette, we're talking about research methods, so let me go ahead and get back to the lecture if I will. So here's the deal. We've formulated a theory by reading the literature. We've then developed a testable hypothesis, something that we should be able to observe if the theory is true. I then select a way of gathering data to support or refute this hypothesis. And after I gather these data, I then analyze these data using a statistics test. But you know what? That is not the last step in the scientific process. In fact, maybe the most important part of the scientific process is then writing a paper and sharing these results with all of the other scientists in my community. And there are tons and tons of journals that are directed at different areas of psychology. If you'll remember yesterday, I talked about the subfields of psychology. You know what? Each and every one of these subfields is going to have at least one, sometimes two or three different journals where people publish research that might be interested to people in that subfield of psychology. Now, why is this important? Well, knowledge and theories build upon themselves. So in order not to keep doing the same experiment over and over again, people need to demonstrate and show what they've already done. And that allows the person in step one to formulate their theory because they go back and read the existing literature. What's in the existing literature? All of the results that have been shared from earlier experiences. And so what you're going to see is this rolling process of formulating and testing a theory, analyzing, conducting a research method, analyzing the data, and then writing up your results so that people can see what you've done and evaluate your research. Sometimes a person may do an experiment or use a research method that is not very good, and people may read their results and say, you know what, I think you've made a mistake. That sometimes happens in the field of science and in the field of psychology especially. And so sometimes people will even do competing experiments to compete against one another and show that the other person is wrong, right? So things to keep in mind. When we develop theories, if your theory is not testable, is not disprovable, if you can't demonstrate that your theory is false, then you can't prove to me that your theory is true. A theory has to be disprovable in order to be useful. Because if you can't show me that in a situation where your theory could fail, it doesn't fail, then I have no reason to believe that your theory is in fact true. So a theory is only good if it is disprovable. And here's the other thing. Theories are always temporary. A theory is not set in stone. Later data may show that your theory is wrong. You know, I remember during the COVID outbreak that we had over the last couple of years, the scientists kept coming out and reporting different suggestions, things that we should do. And so we should wear masks, maybe we shouldn't do this, we should do this, we should do this. And all of my friends who didn't understand research methods said, look at that. These scientists don't know what they're talking about. They keep changing their recommendations. Here's the deal. Those scientists weren't changing their recommendations because they didn't know anything. They kept changing their recommendations because each bit of new data helped them learn more. And so every time they gave a new recommendation, it was based on the fact that they had some new data which suggested that they needed to refine their theory and refine their advice to the population. So in good science, theories are going to change. So don't take that as a weakness of science. That's actually a strength of science, okay? Now, here's the deal. And remember, the most important part of this process is sharing your results. If you share your results, you allow the community to grow their theories too. In fact, the scientist that does research and doesn't write their research up and share it with people is actually not a good scientist at all. So keep those things in mind. I see we have the Crafty Table here today. Hello, Crafty Table. I forget your name again. If you could, go ahead and type that in the chat bar so I'll know who you are. Okay, so here's the deal. There are three broad methods for making measurements to test hypotheses. Each of these methods has strengths and weaknesses. And if you see this chart right underneath me, this is the chart that's in your textbook that's going to kind of give you a graphical representation of how these methods relate to one another. You'll notice that there are three broad categories of research methods. There are descriptive methods, where we just go out and describe what it is we see numerically. There are then correlational methods, where we look at two variables and see if they change in relation to one another. And then we have these things called experimental methods, and they're over on the far right. Now, the descriptive methods, you'll notice underneath the descriptive methods, there are three different ways of doing descriptive research, and we're going to talk about each of those methods today. So I want you to know that as we go through this book, we're going to be talking about theories that we've developed from descriptive methods, from just observing things. We're going to talk about theories that we've developed for just measuring things that tend to occur in the environment. And then we're going to talk about research and theories that we've developed based upon very rigorous experiments that we've set up and done. Okay, I'm sorry, Anna. Sometimes my memory is not as good as it should be. I'm getting a little bit older. Okay, so in a descriptive method, we simply observe things. And this is good for preliminary research or unique situations that can never occur again. Sometimes we'll just go out and measure things. In the correlational method, we look at the associations or the relationships between variables. The earlier thing that I talked about on the previous page, what was it? The self-esteem and lack of social interaction. Basically, that's a correlation. I go out to a bunch of people and I ask them, hey, how many friends do you have? And I have them fill out a self-esteem questionnaire. And I look to see if those two variables, the number of friends you have and your level of self-esteem, change together, if there's a relationship between those two variables. And experimental methods are typically the hardest things to set up. They require the most laboratory control, and they require the most artificial situations, but they do allow us to demonstrate that a variable causes another variable. That's key. Cause is very important in research, because if you can show that a variable causes another variable to change, then you really understand the relationship between those two variables. So let's go ahead and talk about these different research methods, shall we? Okay, descriptive methods. There are three different types of descriptive methods. The first is what we'll call observational studies. In an observational study, basically we go out and create a systematic process for just making measurements of people we see that either come into our lab or that happen to be acting out somewhere in the world. The experimenter has little or no control over the situations. We're just going out and measuring people's behavior. I remember I heard a talk from a researcher at the Arizona State University, and he was interested in people's littering behavior. And he would basically spread papers and flyers on people's cars and parking lots, and then he and his researchers would hide in the parking lot, and they would observe what people would do with those flyers on their car windshields. Did the person take that flyer with them, or did they ball it up and throw it on the ground? So he was simply observing people's littering behavior. And so that's what's known as an observational study. I remember a public health researcher that was interested in hand washing behavior. And this gentleman and his research assistants spread out around the campus that they were on in bathrooms and watched what people did when they finished using the bathroom. Did they wash their hands, and did they use soap? And his conclusions about people's hygiene behavior was absolutely shocking. You wouldn't believe it. But basically in this situation, all the researcher is doing is they are just observing people's behavior and measuring what they do. Probably one of the most famous research experiments is over here. There's a picture of it. Mary Ainsworth Strange Situations Experiments. Basically, she would bring primary caregivers, typically moms, into the laboratory with their toddler children between the ages of 6 months and 2 years of age. She would bring them into the laboratory, and then she would have the mom or the primary caregiver get up and leave the room. And the babies would always start crying. Babies always cry when their mamas leave them. And then what she observed was, how did the baby react when the mother came back in the room? Okay, did the baby quit crying quickly? Did the baby keep crying? Or did the baby seem angry? And she found that babies tended to have one of these three responses. Most of the babies quit crying immediately and became very, very happy. Some of these babies had trouble stopping their crying behavior. And bizarrely enough, some of these babies seem to be angry at their mothers. And she developed a theory of what she called attachment styles in children based upon this laboratory observation study. Okay, she didn't manipulate anything. She didn't measure the relationship between variables. She simply just looked at how babies responded to their mothers when their mothers came back in the room. Now, if you'll notice right underneath me, I talk about naturalistic settings. There are two different kinds of observational studies. There are what we call laboratory observations and naturalistic observations. Mary Ainsworth did a laboratory observation. She brought the children into her laboratory with their primary caregivers, and she watched or observed how the babies reacted in the laboratory setting. You know, the problem with a laboratory setting, though, is it's a little bit artificial, and a lot of times the subject, the participant, knows they're being observed, and so they may not act like they normally would. On the other hand, my colleague Bob Cialdini, who was studying people's littering behavior, put those flyers on people's cars in a parking lot, and then he hid in the parking lot. And these people never knew they were being observed at all. Bob Cialdini was doing naturalistic observation. And although naturalistic observation, it's harder to control people and know what their situation is like, you tend to get a more realistic behavior because the person has no idea that they're even in a research setting. So we have naturalistic and laboratory observations. Now, what's the advantage of the observational study? Observational studies are rather easy to set up. I bring the baby into the lab and I simply measure and observe how they act when their primary caregiver comes back after a period of separation. Bob Cialdini simply observed whether or not people threw the flyer on the ground or kept the flyer in their car. Or the other researcher that I told you about who did the hand washing behavior, they simply hid out in bathrooms and watched whether or not people washed their hands. They're fairly easy to set up because you don't need to control the setting and you don't need to control the participants you're looking at. What's the disadvantage? Well, this lack of control that you give up and the ease that you get makes it difficult to draw conclusions about whether or not one variable affects another variable. I don't know what happened between these moms and their babies before they came into the laboratory. Maybe some of these moms yelled at their children before they came into the behavior, and that's why the kids acted angry. I don't know that. Maybe some of these babies hadn't been with their mom for several hours, so when they came into the lab, they were especially lonely and clingy, and that's why they kept crying when their moms came back in the room. I don't know because I don't have any control. So I really can't say what variable causes the crying or the lack of crying behavior. I'm simply just making an observation about a variable of interest. But observational studies are very good when you're at the beginning of a research paradigm and you want to find out what variables you should measure. Descriptive measures, observational studies are very, very useful sometimes. Now, another descriptive research method is what we call the case study, which is an observation where n, or the number of people that you're looking at, equals 1. So a case study is typically an in-depth study of one individual, sometimes a couple individuals, usually people with very unique situations that can't be replicated, okay? And most of the research that I'm going to talk about with case studies in this class are where people suffer brain damage, and then we measure what kinds of behaviors they have difficulty doing. And a lot of what we know about the brain and what different parts of behaviors, different parts of the brain control occurs in the context of case studies. So somebody will come into a doctor's office or a neurologist's office and they'll say, wow, I've had this specific brain damage and I'm having these kind of difficulties. And that doctor, if that doctor is clever, they will use that as an opportunity to learn about how the brain works. So what we're going to talk about in chapter 2 is this area called Broca's area, which is in the front part of your cerebral cortex, in the frontal lobe. And it's this little spot in your brain. And this French doctor named Paul Broca, back in the 1800s, the 19th century, had a patient named Tan. They called him Tan because that's the only word Tan could say. Tan could not speak. He had one word that he could get out, the word Tan. Well, when Tan died, Paul Broca did an autopsy and opened up and looked at Tan's brain, and he found that Tan had a lesion or a damaged spot right here in the frontal lobe. And Paul Broca said, wow, I'll bet that area is responsible for language production. And we now know 150 years later, beyond a shadow of a doubt, that Broca's area is responsible for the motor production of language. Moving your lips and forming your words is controlled right here in the left part of your brain, in the frontal lobe. Now, what's the advantage? We can really learn cool things from unique cases. So anytime we have people with brain damage and these bizarre behavioral problems, we can really learn about how the brain and nervous system works. Now, could you go in and destroy the front part of somebody's brain to see what happens? Absolutely not. That is completely unethical and illegal. But if it happens, we can use that sad event as an opportunity to at least learn something. So these unique cases do help us develop insights into how the brain works. Okay, and they allow us to study things that we couldn't do ethically. In a sense, there's a research of, oh my goodness, the wild child, the wild child. What happens if you aren't exposed to language during the first years of life? Will you learn? Can you learn how to speak of life? And oh my God, I can't believe I've forgotten her name. The wild child, Zany, the wild child. There was this girl who was raised in total isolation who kept her tied to her crib and locked her in the room for the first 10 years of his life. And he wouldn't let anybody talk to this girl. And he fed her by slipping food through her door. And when social services and the police finally found out about this young lady, she was 10 years old. She weighed 43 pounds, which is incredibly small for a 10-year-old girl, and she could not speak at all. And so, although we could never do that, the scientists were interested in discovering whether or not this young lady could ever learn how to speak, because she hadn't learned to speak in the first 10 years of her life. And you know what? It turns out that she was never able to learn how to speak properly because she had missed what's known as a critical period for languages. So these case studies really allow us to measure things when we can't ethically set these kinds of experiments up. What's the disadvantage on the other hand? It's hard to generalize from just one person. Did you know that 90% of people have Broca's area in this part of their brain? 90% of right-handers have Broca's area on the left side of their brain. You know what that means? 10% of right-handed people have Broca's area on the right side of their brain. So what if Paul Broca had been a right-handed person? There's a chance that Paul Broca might have thought that Broca's area is in the right side of the brain, when typically it's in the left side of the brain. And so it's hard to generalize from one person. Maybe this one person is unique and different from everybody else. But case studies do provide us unique opportunities to do these kinds of research studies. Surveys. A third kind of descriptive method is what we call a survey or a self-report measure. We can basically give a person a questionnaire to measure a certain personality trait. Did you know that there is an adult romantic attachment style which measures how you like to have romantic relationships? Did you know that there is a stress inventory scale which will measure how much stress you're going through at this very moment? When we get to chapter 13 or chapter 12, I'm going to have you take a personality inventory called the Big Five. And I'm going to be able to find out if you're a neurotic or an anxious person using that scale. As I told you earlier, there's a self-esteem scale, which will tell me how high your self-esteem is. Or did you know there's even a questionnaire which measures whether or not you are clinically depressed? It's called the BDI, or the Beck's Depression Inventory. And surveys can allow us to measure qualities about people by asking them directly. I don't have it under here, but the disadvantage of surveys and self-report measures is that people can lie on them. If they decide not to tell you the truth, then you may not learn the truth about how this person is functioning. All right, so these are your 3 descriptive methods. Now, famous case studies. Jeannie the Wild Child, that's the one. Jeannie the Wild Child, raised in total isolation the first 11 years of her life. And she demonstrated that if you do not get exposed to language within the first couple of years of your life, you will never learn how to speak properly. Right down below me is a fellow named Henry Molaison. He had to have part of his brain removed because he had really severe seizures. And the doctors removed the hippocampus, which is a part of his brain responsible for making new memories. And after the doctor removed this guy, Henry Molaison, was never able to learn anything new. And so doctors realized that your hippocampus is the part of your brain that helps you remember new information. If you're going to remember what happened in this lecture today, your hippocampus has to be active. If you have a damaged hippocampus, you'll never be able to learn anything new. Okay, any questions so far? Now, here's the thing. The best way to do science, the best way to come up with, I should say, to develop causal connections between variables is to do what's known as an experiment. And why do we want cause? Well, we want cause because if you know how a variable is going to react in a certain situation, then you really understand what you're talking about, okay? If I really understand the theory of gravity, then I can explain what's going to happen when I drop this paper and this pen. And you know what? They're going to drop at the same time. If I know why that happens and I can predict that, then I understand the theory of gravity. So what we want to do is experiments allow us to say that variable A causes variable B, and it allows us to feel confident about our conclusions. In an experiment, what you do is you get a variable of interest called an independent variable. It is the cause. It's the variable that we think impacts another variable. And what we do is we change that independent variable and we see what effect that has on an effect variable we call a dependent variable. So for example, let's say I think that students who sit in the front of a classroom, okay, learn more than students who sit in the back of the classroom. How many of you sit in the front of a classroom when you go into a seated class? How many of you are like me and always go to the back of the classroom so the teacher can't see you, right? Well, I might have a theory that students who sit in the front of the classroom see more, get more out of the lecture, pay more attention, and learn better. So what I'm going to do is I'm going to set up an experiment. I'm going to do that with my 10 a.m. psychology class. I'm going to go to the whiteboard real quick and show you, diagram how that I'm going to do this. So I have a pool of students. It's my 10 a.m. class. All right. Now, what I'm going to do is when the students come in to the classroom, what I'm going to do is randomly assign students to sit in the front or sit in the back. Okay? So as students come in, I'm going to say, okay, you sit in the front of the classroom. Okay, you sit in the back of the classroom. You sit in the front of the classroom. You sit in the back of the classroom. So I've got 2 students. So this is my independent variable. And it's where you sit in the class. Where you sit in the class. Okay, do you get that? And then what I do is, after the first month of class, I give the students an exam. And what I do is I measure their score on the exam. Okay? Score on the exam. And here's the deal. Let's say we have a questionnaire, and this is your score on the exam. And students who sit in the front and students who sit in the back. And let's say that my students who sit in the front, their average grade equals 85. And let's say students who sit in the back, their average grade is 65. Okay? Now, what I can conclude from this is that sitting in the front of the classroom allows you to get a better grade than sitting in the back of the classroom. And this is what's known as the dependent variable right here, the score on the exam. And whether or not you sit in the front or the back is what's known as the independent variable, right? The independent variable. Because I think that this causes your score on this. Does that make sense, folks? I hope that makes sense. Yes, no, maybe so. Hopefully that makes sense to you. All right, let's go on with the lecture. Now, the key to an experiment, the key to an experiment is this thing called random assignment. Random assignment. And if I go back, actually, let me show you really quick. The key to this is the random assignment. This is the key to an experiment. This right here is the key to the experiment, random assignment. Because what I have to do is I have to make sure that I have the same type of students sitting in the front or sitting in the back. Here's the deal. Students who score high on tests tend to like to sit in the front of the classroom, maybe because they're better students. And those students who are kind of lazy and slack, like me, may tend to sit in the back of the classroom. If I let students pick where to sit in the classroom, maybe the students who sit in the front are just more motivated than the students who sit in the back. So what I have to do is I have to use random assignment. I can't let students pick where they're sitting in the classroom. I instead have to tell them where to sit in the classroom. Does that make sense? Now, here's one method of assigning my students to where they sit in the class. And tell me if this is random assignment. I have 20 students in my class. The first 10 students who come into my class, I'm going to make them sit in the front of the classroom. And the last 10 students who come into my class, I'm going to tell them to sit in the back of the classroom. Now, is that random assignment? Is that random assignment, or is there a difference between the students who wind up in the front of the class and students who wind up in the back of the class? Please tell me, what do you think? Is that random assignment? Cielito, are you? Why is it not random, Ryan? Good answer, but tell me why it is not random. You are absolutely right. You are absolutely right. Oh, actually, I've got the answer underneath here. Bad random assignment. I told you that. So that was an easy. I don't believe it too. But why is it not random? What could be the difference between the first 20 students to come to class and the last 20 students to come to class? Why? Who tends to come to class first, and who tends to come to class late? The people showing up late might be a certain way compared to the people showing up earlier. Exactly. They may be more motivated, Ryan. Right. Jimbro says traffic, distance from school. Yes. Right. Maybe if the students who have more traffic are more stressed and they're not going to focus as well. Maybe the students who live farther from the school have less time to study. The key is it's not random assignment, so I can't say that my two groups are the same at time one. So if I look at their grades, the students who sit in the front, if they come in first and I put them there, these students may be more motivated, they may be less stressed, there may be a ton of reasons why they do better. And these students may be less motivated, they may be more stressed out, they may have less time to study. And so there may be an initial difference between these two groups. In order to really say that these two groups are similar at the beginning of this class, I have to take away any ability for them to self-select into one group and other. A good way to do that is with random assignments, slips of paper, 1s and 2s. Or you might roll a dice, and if a student gets an even number, they're in the back of the classroom. If they get an odd number, they're in the front of the classroom. And yes, Anna, you are right. They might be better students. So the key is and that's why an experiment is so difficult to set up compared to any other kind of experiment. It's because the experimenter needs to control the assignment of people to one condition or the other. And it's that control that gets difficult, because when you're telling people what to do, they A, know that they're in an experiment, and B, you are sort of changing the situation up, and you need to be able to control their behavior, okay? So in a sense, the control is the part that makes it different for an experiment, okay? Now, you know what? Sometimes we can't set up a true experiment where we can test whether or not A causes B, but we're still interested in a relationship between two variables. So in these situations, we do what's known as a correlational study. And basically, we find two variables of interest, we measure them for a group of people, and we see if there's a relationship between one variable and another. Did you folks know that there is no experimental evidence showing that smoking causes cancer in human beings? Did you know that there has never been an experiment done to demonstrate that smoking causes cancer in human beings? Can anybody tell me why there is no experimental study showing that smoking causes cancer in human beings? Does anybody know why we don't have an experiment showing that? Anybody know why? It may take actual years to develop that, but there's a more obvious answer. Good, Lewis, it would take a long time, but there's a more obvious answer. Okay. Let's see. Here's what it's too hard to control for. Yes, keep going, Rylan. Keep going. You're almost there. Keep going. Check this out. Here's an experiment I'd like to propose, and let me see if you folks agree with this. I want to discover whether or not smoking causes cancer. So my dependent variable is whether or not you get cancer. Here's what I'm going to do. I'm going to go into Mrs. Smith's third grade class. And you know what I'm going to do? I'm going to randomly select half of those students by having them pick a 1 or a 2 out of a hat. And all of the kids who pick a 1, I'm going to give them cigarettes. I'm going to teach them how to smoke, and I'm going to give them cigarettes. And I'm going to tell these other kids not to smoke. And then I'm going to have them smoke for 20 years. And you know what I'm going to find out? These third graders are probably more likely to develop cancer than these third graders. Can anybody tell me what's wrong with this experiment? What am I doing wrong in this experiment? Can anybody tell me? Can anybody tell me what's wrong with this experiment? It's unethical, but nobody said I was ethical. But you're absolutely right, Hobo Drew. It is unethical to do that. I wouldn't want to create more cancer patients. But you know what I can do? You know what I can do? I can look at people. I can do what's known as a correlational study. And I can do this. I can do cancer rate. And then I can ask people, do you smoke and how much? Right? And some people say, no, I don't smoke. Some people say I smoke 1 pack. Some people say I smoke 2 packs. Some people say I smoke 3 packs a day. I knew a fellow one time who smoked 4 packs a day. And then what I'll do is I'll find that people who don't smoke are less, their cancer rate is pretty low. People who smoke 1 pack may tend to a little more likely to get cancer. People who smoke 2 packs are more likely to smoke. People who smoke 3 packs and people who smoke 4 packs. And I have what's known as a scatter plot, where I ask you how many packs you smoke and what your likelihood of cancer is. And what you'll see is this linear relationship we call a regression line. Okay? And this is what's known as a positive correlation. As A increases, B increases. Okay? Does that make sense? Does that make sense? You know what? I could do another correlation, and I could do your grade on this exam and the number of beers you drink the night before. Some people didn't drink at all. Some people had 2 beers. Some people had 4 beers. Some people had 6 beers. And you know what I might find? The people who didn't drink, they tended to have high grades. The people that drank a little bit had lower grades. The people who drank 4 beers had lower grades. And the people who got wasted the night before class all had really low grades. And this is my regression line. Do you see that? It goes a different way. This is what's known as a negative correlation. This is as A increases, B decreases. This is what's known as a negative correlation, okay? And so, if we look at this, what you're going to see is in a correlational study, we can't control a variable, but if it's not ethical to control a variable, we can still measure a variable in something we think it's impacted, and we can see if there is a correlation or a relationship. And there are things called positive correlations. So for example, IQ and academic achievement. The higher your academic score, the more likely you are the higher your IQ score, the more likely you are to do well in school. On the other hand, the more alcohol you drink the night before an exam, the less well you will do on your grades. Okay? So in a sense, we can look at the relationships between these two variables. Now, the strength of a correlational method is you can look at relationships where the experiment is unethical or impossible. And it can be done in real-world situations. However, we cannot prove a causal relationship between two variables. Maybe the students who drink too much also do drugs. So is it the drugs or the alcohol that's causing the poor grades? Maybe people who smoke too many cigarettes also drink a lot of alcohol. So is it the smoking that causes the cancer, or is it the drinking that causes the cancer? It's harder to demonstrate a correlational relationship. Okay. You know what? I am now at the end of the lecture. It is 9:56. I ran over just a couple of minutes, but this was a lot of information in Chapter 1. So over the course of the semester, I'm going to be telling you about case studies, observational studies, correlations, and experiments. And I want you to understand that these are the different methods, each with strengths and weaknesses, that can help us learn and make observations and measurements. And this is what makes psychology a science. Does anybody have any questions? Anybody have any questions? I'm going to go ahead and close this lecture out because I've got another lecture starting in another class in 4 minutes. But don't forget, you have a discussion board to do at night tonight by 11:59 p.m. You have to make one original comment and respond to 2 other people to get full credit. This is due by 11:59 p.m. And don't forget that your first homework is due tomorrow night at 11:59 p.m. If you have any questions, don't hesitate to send me a text or an email, and I look forward to seeing you next Monday morning at 9 a.m. Hey, take care and have a great day. Bye.